Classmates, this is problem 9, page 85. Now with this particular problem, we're going to be accumulating money periodically. We're going to go through a period of time where we're not continuing to make deposits, but we'll be accumulating interest, compounding interest during this period. And then we're going to be making withdrawals. You can put minus signs out here to indicate that. And special requirement for this problem, you want to leave $2,000 in the account immediately after the last payment instead of 0. So this is like a retirement problem. When you're accumulating money, you want to make some withdrawals over the rest of your life, then you want to leave an amount of money maybe to a charity. So how much can you withdraw given your deposits and given your charity requirement? So the first thing to do is compound the 3 $1,000 payments to some point in time. Again, I have a little bit of a bias toward using an ending setting. So I encourage you to work this problem, work with this part as a beginning setting, but for now just work it as an ending setting. The ending setting, future value of an annuity, accounts for, in this problem, 3 payments in 2 compounding periods. So that tells you exactly the point in time where you're going to compound these cash flows. And that's the time period 2. 1,000 is payment, 3N, 10I, 0 PV, compute FV. 3310. So you've accumulated 3310 at time 2, and then now you're thinking ahead out here to these withdrawals. At keeping your setting on ending, you know that this amount, 3310, is the present value of this of these withdrawals that are in an unknown amount, as well as this withdrawal of $2,000 in a known amount. So you're thinking present value of an annuity. So go to your present value of annuity formulas and use either the ending or beginning setting to position this cash flow, compound this cash flow on your timeline. You've got your calculator set to ending, so you might just use ending setting. That accounts for 3 payments in 1, 2, 3 compounding periods. Ending setting associated with a present value of an annuity. So that tells you, this is very important, this arrow, it tells you exactly where you're going to compound this cash flow to. And, of course, the number of compounding periods that you're going to compound, and that's 3. So enter 33,100 is PV, 3N, 10I, 0 payment, compute FV. And at time 5, we have 4405.61 accumulated. Now we've got to use this amount to make this withdrawal as well as these withdrawals. So given this withdrawal, how much are we going to have remaining in order to make these unknown withdrawals? Now, watch very carefully. Withdrawing $2,000 at time 8 is the same as withdrawing the present value of $2,000 at time 5. So I'm going to take $2,000 as FV, 3N, 10I, 0 payment, compute PV, and the present value of that $2,000 at time 8 that is expected to be received at time 8, the present value of that amount at time 5 is 1502.62. And again, subtract as we have the minus sign out here. And that amount remaining 2902.98. Now this amount is the present value that we have remaining that can be used to make these unknown withdrawals. So to solve for X, 2902.98 is PV, 10I, 3N, ending setting, 0 FV, because we've already accounted for this $2,000, bringing it back, discounting that amount back to time 5, compute the payment, and that's 1167.33. Now, alternatively, you could do this. You could enter at this point where you've calculated 4405.61 as your PV at time 5. You could enter 4405.61 as PV. $2,000 is a negative number for FV. That is very important that that is entered as a negative number. 10I, 3N, compute your payment, and you come up with this same amount. But be careful. If you would have compounded the 3310 out to times 6, you would not have been able to solve the problem by entering the $2,000 as an FV. So that's a big reason why I caution you to work a problem like this one step at a time, so you'll know what you're doing, and try to avoid entering, for example, an amount for FV and PV at the same time to solve for payment. And that concludes problem 9 on page 85.